Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of laws of exponents, specifically how we handle rational exponents, and we'll do it in 5 minutes or less. So if we look on our mathematics chart, we will see something that looks like this in the section called laws of exponents. We're going to see a to the m over n power. That's kind of a weird notation. And so what that means here is that we're going to take a, and we're going to take it to the m power, right? We're going to keep the numerator as our exponent, but then we're going to take the n root of it. So we can end up taking this fractional notation in our exponent and turn it into a root. So how does that work? Well, let's start with something pretty simple, right? So we might end up seeing x to the 1/2. Okay, so that's a pretty standard. Well, what does that mean? We're going to take x, that's our base, right? And then the m term, the numerator, that's going to end up being your exponent. And then you're going to end up taking the denominator as the root. Okay, so that's the square root, since it's got that 2. Typically, we'll just kind of drop it off. So really, if you want to simplify it, it's just the square root of x. Right, because x to the 1 power, anything to the 1 power is just, itself. And then typically we'll drop the 2 when it's a square root. We'll only put a number if it's something other than 2, like a cube root, we'll put a 3. Okay, so let's plug this in just to make sure. Okay, let's take something that we know is a perfect square, right? So we're going to take like 9. Let's take 9 to the 1/2 power, okay? So we're going to end up saying, all right, this is 9 to the first power, and then to the square root, and then we're like, okay, this is going to be just the square root of 9, so that's going to end up being 3. Now, 9 to the 1/2 power, right? You can open up your calculators and just do it, right? So if you've got just a regular calculator, you would do 9, and then you do that little caret to show the exponent, and then go ahead and put your parentheses on and just do a 1 over 2 or 1 divided by 2, and you're going to show that it is 3. Okay? Now, let's take a look at one that's a little bit more complex. Right? So we might say x to the, the 5/3 power. Right? And let's say we simply want to just simplify that for some reason. Okay? So what we would do is we would say, all right, we're going to take our base, x, okay, and we are going to go ahead and take it to the 5th power, but then we're going to wrap that inside a root. In this case, it's a cube root, so that's what that equals. Now, at this point, that's as simple as we get. Okay, that's a simplified version, and we can go from one to the other, right? So sometimes we'll get something that looks like this. We might say x to the 7th, take that to the 4th root, and we'll need to translate that back into, all right, keep my base. My exponent inside the square root is my numerator. The type of root is my denominator, right? We need to be able to go back and forth. But let's see if this worked with numbers. Okay, so let's say in this case, x equals 2. Okay, so we're going to say x equals 2, so we're going to take 2 to the 5/3 power, so that's going to end up being 2 to the 5th power, take the cube root, right? We can do this in 2 chunks on our calculator. So 2 to the 5th is going to be, that's 32. Really, so what that ends up being is that's going to end up being the cube root of 32, right? So then if we take that cube root of 32, we are going to see that it is going to be, it's going to be like 3.17, okay? It's not going to necessarily be anything like an integer. Or, take a look at this 5/3, right? This 5/3, is really, if we wanted just to go straight to, and then just like we did this, to the 5/3, rather than doing it separately, it's going to be that 3.174808. So you could do it kind of either ways, and that's how we take rational exponents.